Hello, welcome to Folder 10. Today, your objective is to be able to solve a system of equations using substitution. Remember, you need one of these worksheets. If you don't have one, just hit pause and go ask your teacher. In this folder, you will have 10 systems to solve. And as a quick review, remember in a system, you are solving for x and y because there's two equations and two unknowns. You may write your answer like that, or you may also write x equals and y equals. Whatever you like to write is fine. Don't forget to put your name, folder 10, today's date, and which attempt. This is my first attempt. And as always, there'll be 2 step-out questions. These questions will relate back to a little bit from folder 9. You'll have 5 minutes to solve these 4 systems. Feel free to hit pause while you write the systems down. Okay, let's go ahead and check your answers. First, I'm going to model number 4. I'm going to be a little out of order here because I want to use this as an example for the step-out question. So think about this problem as we work through. Now, I know y is equal to 3x minus 11, and there's different ways I could solve this. What I'm going to do is I'm going to go ahead and solve for y in the second equation. So now I have y equals 3x minus 11 in the first equation. In my second equation, I'm going to add 3x to both sides, and now I have y equals 3x minus 13. This is a favorite way of mine because I love to set y equal to y. So I think that is so easy to do. So where it says y here, I'm going to substitute in 3x minus 13. So I'm going to get 3x minus 13 equals 3x minus 11. And some of you might already know that I can cancel 3x from both sides. I'm going to go ahead and just subtract 3x from both sides. And these cancel down. I'm left with negative 13 equals negative 11. I'm going to stop there because this is not a solution. There is no way I could solve this. These will never equal each other. So in this system, there are not any solutions. If I ever want to think of a quick picture of this and I graphed these two, they might look something similar to this, and this is not a great, this is just a sketch, okay? They're parallel lines because the slope is the same, but the y-intercept is different. So they will never intersect. And we know that if systems never intersect, there is no solution. So right here, this is no solution to this answer, to this system. So I do have a quick step-out question for you. What types of solutions can a system have? So I'll give you a little hint. There's 3. Why don't you go ahead and write out what types of solutions you can get when solving a system. Okay, I'm going to move on to my next model. My next model is y equals 8 minus x, and 7 equals 2 minus y. Again, I always have to look at it and see what my choices are. When I look at this second equation, I notice that there aren't any x's in there. And I'm going to see if I can get y by itself. So in order to do that, I'm going to come over here, have a little bit of room, and I go ahead and subtract 2 from both sides. I get 5 equals negative y. Well, I still don't have y by itself, so I'm going to divide both sides by a negative. And if you like, you can always put a 1 in there. It's very helpful for some people. So I get y equals negative 5. As I go back to this equation, I would have 2 minus 5, and that does give me 7. So that's pretty good for my y. Now I know in a system, I should have an answer as an ordered pair. So go back up here. I'm going to put in negative 5 for y. Negative 5 equals 8 minus x. I'm going to go ahead and subtract 8 from both sides. I get negative 13 equals negative x. And again, I divide both sides by a negative. So x equals 13. Come back over here, and I know that x equals 13. And 8 minus 13 is negative 5. So it looks like I did a pretty good job. I may put my answer also in an ordered pair if I wish. Or I may write x equals negative 13 or y, and I can put an and between them because I need both answers for this solution to be complete. Here's step out question number 2, and this is when I mentioned to think about folder 9 in your previous learning. What does it mean when a system has an infinitely many solutions? And here are the answers to 1 and 3. Notice in the answers, I wrote them in 2 different ways. I want you to make sure that you know you can turn in your answer in either way, right? Okay, remember a common error sometimes we see is the x and y are flipped, so be careful that doesn't happen. It's really nice that you can go back in and check your work pretty quickly. So remember, in a system, the answers have to work in both equations. So always make sure you check both equations. Okay, you're going to have 5 more minutes. First, what I'd like for you to do is name an error that you made, and what can you do not to make that error again. Something I do is I like to put parentheses, and that protects my signs, reminds me of distribution property. So that's something I do. Okay, sprint number 2. Again, you will have 4 systems to work with. Remember your answers. You need an x and a y, or infinitely many, no solution. All those work also. Okay, you have 5 minutes. Feel free to stop and hit pause, write down your systems, and then come back. Okay, let's check your next sprint. Here are your answers. Number 1, x is 3 and y is 6, or you may put it in an ordered form. Same thing for 2. Number 3, infinitely many solutions, so they're the same line. And number 4 has no solutions. To end this, we just have a quick reflection. How many did you get correct this time? Okay, let's go ahead, and if you got a half of one right, let's make sure we mark that down somewhere. Did your score improve? And by how much? Go ahead and turn this paper into your teacher. Thanks very much, and have a good day.